For case 8, mass on an inclined plane with friction. We've got same layout as last time, but with the added friction. So we got mass 1 on the inclined plane attached to mass 2 through a string, and mass 2's dangling, hanging over the edge. Free body diagram for mass 1. We've got force of gravity pulling down. It's got to be separated because it's on the plane into force of gravity X and force of gravity Y. The normal force is pulling opposite of force of gravity Y and canceling that out. And force of tension is pulling it up the inclined plane. And so the only forces that will cause acceleration for mass 1 are the force of gravity X and force of tension. For mass 2, its free body diagram has force of gravity pulling it down and force of tension pulling it up, just like case 7. Mass 1, positive acceleration. Mass 2, negative acceleration. Okay, need some room. Step 2. We got this is equal. So A1 is positive and A2 is negative. A1 is equal to A2. So we'll just call that A, acceleration. They got the same acceleration because they're going to be moving. They're going to be moving at the same acceleration because they're connected with tension. Speaking of tension, the force of tension acting on mass 1 is equal to that acting on mass 2. Because it's the same rope, so it's just going to be called force of tension. Step 3, we got to do our F net equals MA equations. Equals mass 2 times acceleration. And for mass 2, its acceleration is negative, so it's going to be negative. For step 4, the net force acting on mass 1, we've got gravity, force of gravity X pulling it down, so it's going to be negative. We got tension, it's going to be positive, and force of friction pulling it down, so it's going to be negative. For mass 2, we've got force of tension, positive, pulling it up, and force of gravity pulling it down. For step 5. For step 5, we have to combine these, make them simplified. So we have force of gravity X plus force of tension minus force of friction 1 is equal to mass 1 times acceleration. Gotta combine these. Force of tension minus force of gravity equal to negative mass times acceleration. For step 6, we have to expand each equation and set it up for substitution for step 7. So the force of gravity X can be written as mass 1 times gravity times sine of theta, or whatever angle it is. It is 30 degrees, but like we're just doing a general. So we're just gonna call the angle theta, subtract or add force of tension, and then subtract the friction, which friction can be written as the coefficient of friction times mass times gravity times cosine of theta. And that's negative, and that's equal to mass 1 times acceleration. And for mass 2, force of gravity can be written as mass times gravity, and that's equal to negative mass times acceleration. We're going to isolate this by putting them on this side, and that's equal to mass 2 times gravity minus mass 2 times acceleration. And then we're going to make this all into one equation by substituting, because we got right here, and got right here. And so all put together, that is mass 1 times gravity times sine of theta plus mass 2 times gravity minus mass 2 times acceleration minus coefficient of friction, mass 1 gravity cosine of theta. And that's equal to mass 1 times acceleration. Next, we gotta simplify both sides of the equation, isolate the variables. Isolate acceleration, factor it out. And so this has gravity on it, this got gravity on it, this got gravity on it, and these two have acceleration. So we're just gonna move this to that side. Mass 2 times acceleration. And so we're gonna factor it out. Acceleration. By the way, this is steps 7, 8, and then it's gonna be 9. Times mass 1 plus mass 2. And for right here, I'm gonna factor out, we're gonna factor out gravity. And so gravity times negative mass 1 sine of theta plus mass 2 minus coefficient of friction mass 1 cosine of theta. It's equal to acceleration times mass 1 plus m2. So we're going to divide that away to get a by itself, to get acceleration by itself. Mass 1 plus mass 2. And then we can write in final step. Step 10, finally solve. And so we can rewrite the whole thing as acceleration is equal to gravity times negative mass 1 times sine of theta plus mass 2 minus coefficient of friction mass 1 times cosine of theta all over mass 1 plus mass 2. And that's our, oh, you can't really see, but that is our final answer.